Hey everyone, so happy Wednesday. I'm not sure if people say that or not, but today, is Wednesday, second week. So the homework will be available today at noon on Lumen Learning. Okay, the first homework that is. It's going to be due on Tuesday by 11:59 p.m. It's again the homework. Excuse me, the homework is not there yet, but it will be available basically at noon today. And again, what I'm expecting to do this weekend is post the quiz. I'll give you like a day or two to complete it. I'll let you know. I'll keep everyone in the loop through the announcements. I'll send an announcement about the quiz and stuff. So, okay. But again, the homework will be available today at noon. Okay. Just letting you know. And again, you have until Tuesday of next week. Tuesday of next week by 11:55. To complete it. Okay. I think it should be in the calendar as well, that the homework will be available. So okay. I'm starting to use that calendar feature on Blackboard. So last semester I didn't really use it. All right, so I did email the notes to everyone. So what I want to do now is I want to finish chapter 1, and then what I'm going to do is I'll start chapter 2. All right, so let me just turn this off. So let me now get the notes. So here. All right. Right, here we go. Can everyone see it? Good, okay. Yeah, okay. Okay, so basically, as you can see today, what I want to work in now is 3 dimensions. Before, we were working in 2 dimensions, right? And, we saw some 2-dimensional figures, shapes that is, like rectangles, circles, parallelograms, and we were restricted basically to the plane. Right? We saw what a plane was. We described it. Now we're going to allow height. In other words, we're going to work in 3 dimensions. We have length and width, and now we have height. It was a little confusing with the rectangle when we looked at dimensions, and I guess the triangle also, because we talked about height there. But there, its height in the plane. Hopefully that makes sense. It's height relative to its base, but you're still in the plane. Here, with height, we're coming out of the plane. So we have length, we have width, and we have height now. So we're working in 3 dimensions now. Okay. Thought someone had a question. I'm sorry. All right. Good. Okay. Thought someone had a question. So again, we're working in 3 dimensions now. Now here we had area in the 2-dimensional world, if you remember. Yeah?
Oh, you're not sharing your screen.
Oh, sorry. Really? I thought it was. Oh, that's weird. Thank you. That is weird. How did I not share it? Thought it did. All right, thank you. Okay, so again, here, let me start again. We're working now in the 3-dimensional world. Okay, and again, we have length and width and height. 3 dimensions here, okay? And let me just say it again because, I wasn't sharing the screen, so let me say it again. When we looked at 2-dimensional figures like triangles and rectangles, the height there was height relative to the base, but you're still restricted to being in the plane. Here, however, when we say height, we mean coming out of the plane. So again, we have length and width, and we have height as well. Yeah?
I'm just confused. What do you mean by coming out of the plane?
Coming out of the plane? Like, it's almost like the plane is how do I say this? Think about the plane as being like the piece of paper, and when coming out of the plane means you can rise up out of the plane, like standing up.
Okay.
Does that make sense?
Yeah.
All right. Well, if you want, well, I'll say it again also when we get to the shapes. That's a very good question also. With volume, remember we had area when we were stuck in the plane, right? Basically, you can go left or, excuse me, when we were in the plane, we had area, and that was in square units. Here, for volume, we have cubic units. So in this case, we're going to have cubic meters, cubic feet when we look at volume, or cubic inches. And these are just some three-dimensional shapes. So if you have a square, a cube here, it's kind of like a square in 3 dimensions. And when I mean coming out of the plane, we had length, right? At the bottom, we had width. And height means if the plane, you can come up. That's what we mean by height, coming out of the plane, going up. Okay. That's what we mean by that. So that's what we have here. With a cylinder, the top and the bottom are circles. They're actually the same circle. They're copies of each other. Okay? This is a cylinder. And then we have also a rectangular prism. Okay? Again, the base here is a rectangle, a 2-dimensional rectangle. But now we have 3 dimensions, so we also have a 3rd dimension, which in this case is up, height, coming up. Or if you want, I guess you could think of it this way. I know someone asked, like, coming out of the plane, what did I mean by that? In 2 dimensions, you can go left, right. You can go forwards or backwards, kind of like north, south, east, west. Here, we're also allowing coming up, standing up. That's basically what we mean. Okay. But this is a rectangular prism. Kind of like a box, I guess, so to say. You can think of it that way also if you want. Now, in the 2-dimensional world, we had area, right? And theoretically, you could calculate area by filling up the 2-dimensional shape, the inside of it, so to say, with squares. For volume, you do the same idea, but you can do it with cubes. But we don't have to do that because just like in area, there are formulas for volume as well. And again, volume is just how much space a 3-dimensional object takes up. That's how much space a 3-dimensional object takes up. Okay? That's what happens here. So for a cylinder, the volume of that is pi times r squared times the height times h, where r is the radius of the base circle, which is a circle of radius r. H is the height. So that's what we have here. So we have pi times r squared. Again, r is the radius of the base, and h is the height. Okay. Now, we had circles in the 2-dimensional world. Here we have spheres. Again, a sphere is, you're given a fixed point, call it the center. A sphere is all points in 3-dimensional world that are the same distance from that fixed point. So again, it's kind of like the 3-dimensional analog of a circle, so to say. Okay. And now the volume for a sphere is given by this, where again, r is the radius of it. Again, the radius is just the distance between the center of the sphere and any point on the sphere. They're all the same distance. Visually, it's the length of the line segment from the center to a point on the circle. From the center to a point on the circle. And you could also consider the diameter of it. That's twice the radius. And visually, it's a line segment whose endpoints are on the sphere, but it passes through the center. So we have spheres. You could think of that as like a, how do I say this, like a ball, basketball, baseball, tennis ball. So you can see, this is the volume. Here we have a cylinder. Makes me think of a garbage can, I guess, although it doesn't have a lid. So we also have formulas for those rectangular prisms, okay? So for a rectangular prism, the volume is the length times the width, as you can see. And again, when we say coming out of the plane, you can, hopefully you can see this. It takes a little visualization. You can imagine having a rectangle of 2 dimensions, just a rectangle that is. But now if we add a third dimension, which is height, here we're stepping up, standing up, so to say, out of the plane. I hope that helps. So, but this is what the volume of a rectangular prism is. Length times the width times the height. In fact, a cube is what you get when these 3, the length, width, and height, are all the same. That's what a cube is. And the volume of it then is just, since the length, width, and height are the same, you take any one of those and cube it. Or in other words, they're all the same, so I'm saying B is the length, width, and height. So the volume is just that number cubed. That's all. Let me pause the recording.